Welcome to another repair video. What we have today is a Lanzar Viberant VIBE266 2000W claimed 2-channel amplifier. A 2000W 2-channel amplifier, the VIBE266. So this is claimed to be the typical not working status. I was going to take the cover off on camera, but there's a huge chrome top to it which really throws the camera off. So I do want to point out the one thing for these amplifiers is underneath the cover you do have a connector, an LED connector, which plugs into the board right here. A lot of amplifiers that I get that come in for service have the plugs ripped off or damaged because the person prior to coming here didn't realize that there was a wire connected to the board. So when they take the cover off, they're not expecting a connector, so they just pull the cover off and pull the plug with it. So from here, what I'm going to do is I'm going to go through and check for any shorted components. So I'm going to fire up my Fluke 87, and I don't know if for all you Fluke 87 owners out there, if you know this trick. You know how on video some people will complain about the beeping of the Fluke 87 on diode mode. So if you hold the speaker button down while turning on your meter to diode mode, it'll say beep if you let go of the button. And now what that does is that just mutes the speaker on the meter, so I don't have to annoy you with the long constant beeps of the meter. So what I'm going to do is I'm just going to go through, I'm just going to make sure I don't have any shorted components. And what you'll see is on a shorted component you'll see either a really low value or zeros across your meter, or if you do have the speaker on, you will hear it constantly beep at you. Same as for when it's charging capacitors. It will continue to beep on you, because remember, when capacitors are discharged, they act as a dead short. So I'm just going around making sure that I don't have any shorted components on the amplifier, on the power supply, and on the output section of the board. Oh, and so I do have it looks like one channel does have shorted. Yes, so this channel looks like it has a direct short across the transistors. Yes, I do have a direct short. So from here, what I'm going to do is I will just switch to resistance. I'm going to figure out which one is bad. So this one here is 21 ohms. This one is 1.5 ohms. And this one is 88 ohms. And this one is 88 ohms. So this one right here. So one of the first things I do when determining which transistors are shorted is I will look on my meter. I'll go across. So what I'll do is I will check the resistance from the base to the emitter of the output transistors, and I will look for the lowest resistance, because that's usually going to be the one that's shorted. And sometimes the other transistors are okay. So what I'm going to do is I'm just going to cut the leg off of the transistor that is showing as being shorted. So what that'll do is what that does is it tells me if any of the others have survived. So I'll go back through. So we're 12K to the base emitter, 12K base emitter, and 11K base emitter. So now these don't show that short that I showed earlier. So by removing the one leg here tells me that I still have 3 output transistors that are still good. Yeah, so what I need to do is, so the base to collector, I'm still showing about 30 ohms, so I'm going to go ahead and pull this other one. I'm going to go ahead and pull this other leg here. Pull that other leg up just to eliminate the collector. Just to check and make sure that the other collector, base collector junctions are still good. So 305K. So yes. So that one transistor is the only one that is shorted. So now what I do is I will pull the transistor heatsink spreader off and see what we got here as transistors. Alright, back where I left off. So now it's time to remove the transistor heatsink spreader to see what transistors are used in this amplifier. So we'll just remove that. And these are TIP 35s. TIP 35C. Let's just check the other side here. And then your other side are TIP 36s. So the other side is TIP 36. These are very common transistors that are used in some of these older, don't know what year this is, but older amplifiers. We'll use 35s and 36s. So what I'll end up doing is I'll end up replacing both these 35s here, because they are in parallel. So you have to replace those as you should replace those as a matching set to avoid any thermal issues, load sharing issues. So now what I'll do is I will just I'll remove the rest of the spreaders, and I will take the board out of the heatsink, and we'll move on from there. Alright, so I was removing the heatsink spreaders here, and then I figured I'd show you that you can pull up data sheets for the transistors that you're using. So for instance, here's the data sheet for the TIP 35s, which will show you the configuration of the legs of the transistor. So you'll see there you have a base collector emitter, and you'll see on the data sheet 1, 2, and 3 from left to right, which then you can see from left to right on the transistors that you're working with, that you can correspond the legs to the data sheet to know there's the collector, or here's the collector, here's the emitter, here's the base. So the base is what drives the transistor to be either an on or off state. And then here's your emitter, which also tells you, well, this is your emitter resistor. So sometimes you'll have these emitter resistors that burn open, or a high resistance value. so that that shows you where the emitter resistor is, or what the emitter resistor is. That's what I like about this board. This board is set up very well for a new technician to learn from, because what they did is they silk screened the top of the board to show the bottom traces, so you don't need to flip the board over constantly to try to determine where the trace is going. So you don't need to worry about flipping the board over to know where the traces are going. So you really can follow the whole circuit of this board based on working from one side of the board. So I'm not sure how many of my viewers are new technicians or people that want to learn how to repair amplifiers, but this is a very well thought out board for someone to learn on. If you want me to make a video of this board and how it functions, this is a Class AB, by the way, on how it functions, just let me know. I'm more than happy to explain the process of how this Class AB amp works, why it's designed the way it is, how it's laid out, because if you notice, if you put a line right down the middle here, you will see that it's mirrored on both sides. So it really does help explain the process on how this works. So please let me know if you're interested in that, and I will be more than happy to make a video on that. A lot of technicians that I know that are Class D technicians don't have a full understanding of the Class AB amp and how the input stage works in conjunction with the output stage. They get kind of lost on how the signal is driven at these transistors to drive your output transistors. Just remember, everything is referenced to 0 volts. Think of it as an oscilloscope. The line going down the middle is 0, and your sine wave is going to be either above 0 or below 0, and that's what the job is of this section, is to pull that above 0 and to drag it below 0. So just a rough idea of how this works in a Class AB. So I will go ahead and remove the board so that I can remove this transistor, and I will verify that the board powers back up as it should. Alright, so I got all the screws out, and I'm very meticulous when it comes to my workbench. So what I do is I take all the screws out, all the spreaders, and I put them in a bag, even though knowing I'm going to have this amp done in just within the hour. Just keeps everything together. I like to have a clean table. So what we'll do is we'll go ahead and just pull the board out. Paying attention to all the thermal pads, insulators, micas. If these had micas, it'd probably start flying around everywhere. So let me remove the heatsink. We get this board on the table. So what we have now is just the board. So what we have now is just the board. So what I'm going to do is I'm going to remove this bank. Again, like I stated, these are parallel, which you can see from the silk screen that these are parallel. So the emitter of this goes behind around to the emitter resistor. The emitter of this one comes over to the emitter resistor here. They combine in the center, and they combine here, and out they go to the speaker output terminal. Just to kind of give you a rough idea of the path my years troubleshooting, we always said, you know, follow the path of the electrons. Follow the electron. Which way is the electron going to go? Like I said, this board gives a great idea of the path of electrons here. So I'm going to go ahead and remove those two TIP35s, and I will be back again. Alright, so I have returned. So then I realized that I probably should use a different camera angle for showing you the base collector emitter on these TIP35s here. So with this camera you can kind of follow along a little bit better. You can see the emitter here. This is the bad one, by the way. The emitter, the collector, and the base. And again, like when I stated how this board is laid out, you can actually follow the base, the jumper goes across, and then you'll see that these two TIP35s go to individual 100 ohm resistors, which then you can follow the signal going back all the way. So this is kind of what I was saying, how I really enjoy the layout of this board, is it really does help explain by looking and not having to flip the board around or follow vias. It really does help explain the layout of how this functions. So what I did is I took my Hacko 808 and I desoldered the legs of these two TIP35s. So I'm just going to go ahead and pull them right out of the board. And there's the two TIP35s, and there's the one that I cut the legs on. There's the one that I cut the legs on. This one is still good. So let me switch camera views here. So this one I will throw out. This one I will actually keep. I do have a bin for miscellaneous transistors, BJTs, for testing and diagnosis of problematic boards where you don't want to burn out, where you don't want to burn up new transistors. So I do keep old transistors just for that purpose. So I'm going to remove the leg insulators if I can. They might be a little older. There we go. So I'm just going to remove the leg insulators here. Because I want to reuse them to keep everything as original as possible on this board. Hopefully, if I can get this one off. There we go. So there's the bad one. That'll go in the garbage. And then I have to pull the insulators off this one because I can't reuse this one because this is no longer a match. So I'm just going to straighten these out so I can get these leg insulators off and reuse these. And then I'm going to set this good one aside. That's going to go in my BJT bin. And I'm sorry, I didn't show you the desoldering process. So probably in a video I'm going to do in another video I'm going to show you the layout of my whole work area. So about 5 feet that way I have a separate bench for tear down, for removal and installation of components, which is why you'll see me swap in and out because my other bench doesn't have a camera setup. So I'm having to move between benches while I do these videos because my other equipment is on the other bench. So now I will put the insulators on the new TIP 35s. These are matched. So there's that, and hopefully these will bend up in place nicely. So let me just get these insulators on. Just like that. So now, again, sorry, I have to move over to my other bench to be able to solder these in place so I don't drag my equipment across all my tables here, and I will be right back as soon as I get these soldered back in place. Alright, I'm back. Got those soldered in place, and now I'm just going to clean up the flux around the solder joints that I made. I'm very meticulous on the cleanliness and the neatness of my soldering, so I'll just clean it on up. Just clean this flux up here. Again, using a technician's best friend, the Q-tip. So we'll just clean this flux up, make the area that I serviced presentable for any future repairs of this board. If there's one thing that customers and clients really appreciate, is quality and cleanliness of the work that you perform. So if you repair amplifiers or thinking of repairing amplifiers as a service, keep in mind the customer or client's board that you're working on. If you want their repeat business, give them good high quality repairs and they will continue to come back to you. This I have learned through experience and my quality. So there's that cleaned up. The solder joints are perfect. There's no cold joints there. It's flowed nicely. You can see the factory soldering is really solid still. There's no cold joint solders here. So I believe this board from Lanzar is probably old enough that it was made before they ended up going the cheaper route, I should say, because all these joints look really good still. I have no concerns about the bottom side of this board. So from here, what I'll do is we will put this board back together. I'm just going to slightly raise these transistors just a little bit just to match the others, so when it goes back into the heatsink they're relatively close to original locations. And what I'll do is I'll clean up all the insulators. I will clean all that up, clean up the old thermal paste, and add new thermal paste to the backs of these, and we'll get it back in the heatsink. Alright, so I got all the insulators cleaned up. So now I'm just going to put the thermal paste on the transistors, which I do use a Dow Corning 340 thermal pastes, which I will add some just to the backs of the transistors, just to the back sides of the transistors here. I'm not afraid to put too much on, kind of like the technicians online that do those Xbox or game console repairs. They say, what is it they say, the perfect amount? Well, business card works great to remove the excess. So then I just take my card and I rake it down the back side of the transistors. To even out the thermal paste while getting rid of any excess at the same time. Thermal paste is cheap compared to the amplifier coming back for service, so I'm not bashful about my overhead cost of thermal paste. I'd much rather have customer satisfaction than having to redo this again because I put too much on or didn't put enough on. So that customer satisfaction is what I'm after. So I'm just gonna rake this across the top of the transistors and then remove any excess as I did for the other side. So I'll just take my trusty business card here and rake off the back of these. And just keep in mind what the purpose of this is not to pull it up behind your transistors, but to help even out the imperfections of the surfaces. So just try to keep that in mind. I do have something on the back. Oh, there we go. I had something on the back side of this stuck. Probably rosin. When you solder in your transistor, sometimes little rosin balls splatter onto the back side of the transistor. So some of you may say it's not enough. Some of you may say it's too much. Well, all I can tell you is I will almost bet I will never see this board again. Board will have 0 failures when it comes to thermal transfer. So that's that. And then I take all my insulators and I will clear off, make sure there's no debris on the insulators, and I will just stick the insulators back onto the back side of the transistors just like they came off, making sure that the holes are in the proper direction. Hopefully, I think the hole was closer. The hole is closer to the board than it is away from the board. So the holes are closer to the board. Slap the other side on, making sure there's no debris on the thermal pads. Sorry for any noises that you hear outside. It is currently snowing, wintry conditions here, as you will probably see across most of the country. Well, same here for the central Washington. It is a cold, snowy mess. So that's all the insulators put back on. This is where I just make sure that the complete back side of the transistors are covered. This just aids when I go to slide this back into the heatsink that I have everything lined up the way I like it, where I want it, and making sure there's nothing in between the transistors and the thermal pads, or insulators, whichever you prefer to call these things. and I'll be right back with you. Alright, so now I'm going to install the board back into the heatsink. So excuse the blaring light if you get any, as I swap this over for the heatsink here. Let me get everything back in view of the camera. We will get this board back in place here. So I gotta flip the board around here. Just like that. So we're just gonna rest this board back into the heatsink. Make sure everything is lined up. Make sure nothing is out of alignment. Everything is still looking good. And then what we'll do is we will take our transistor spreaders and screw them back down to the heatsink. We'll put some power in this and see what happens. Alright, and here's a little tip for when you're installing your boards back into the heatsink. Is if you do the end plates first, you'll stand a better chance of having everything aligned properly. So when you go to screw down the transistor hold, or when you go to install the transistor hold down first, before you screw down the end plates, what could happen is when you're tightening down the end plates, it could put pressure on the board because those transistors, once you screw them down, they're not going to go anywhere. They're going to be where they're at permanently. So the end plate will really help set up the board to be in a proper position. Which these screws are much smaller than the transistor screws. So if your transistors are out of alignment on the heatsink, you'll put more pressure on the screws for the end plates, which these screws can break if you're not careful. Sorry for my arm reaching across the front of the view here as I try to get this corner screw installed, because like I said, the end plates kind of set up the scene for where the transistors are gonna fall into place. So what I did is I secured just the center. These just hold it down, and then I did the end plates, which sets the board left and right to limit the stresses on the transistor legs, because there are some amplifiers that I come in that are in need of repair just from transistor legs that are broken from stress, especially like in the jail audio amps. They're notorious for breaking the transistor legs, but if you set it up properly to begin with, you won't put any stress on those legs. So now the end plates are screwed into place. I can go ahead and seat these transistors. Make sure all the thermal pads are covering the transistors 100%, so we don't have any shorts between the back of the transistors and the heatsink. So I'm just going to make sure everything is lined up properly. Make sure everything is covered. Make sure all the backs are covered. So to prevent any shorts, which everything is looking good. It could come down just a hair on this one, just a little bit, because it looks like the bottom is exposed. There we go. It was exposed just a little bit. Got that taken care of. So now we're good to tie down these transistors. I'll be right back with you. All right, I have returned. I've got the heatsink transistor spreader bars installed and torqued down. So I have a temporary fuse installed here. It did come with no fuses installed, so I have installed some fuses, and I'm going to hook up my 12 volts. And we will see if I have a functioning output section. So let me get my 12 volts going here. So and you can see I've got the scope set up in the upper left hand corner of your screen, so you can follow along with me on the visuals. And again, this is a 12 volt 2 amp current limited power supply that I'm using, so it won't exceed 2 amps regardless of the size of fuse that I have installed. This only applies to testing and troubleshooting. Don't install a bigger fuse into your amplifier while you're hooking it up in your vehicle. That could have bad outcomes. So I'm going to turn on my 12 volts. I'm going to ground my scope to my closest ground point, which I'm going to ground well, I was going to ground the terminal, so let me find me a good ground point here, which it looks like they are not running their ground on the transistor tie. They're not running that through a capacitor like they typically do. So I'm just going to go ahead and connect to the chassis, since it looks like the chassis is grounded direct. So let me get my channel 1 set up here. Let's verify my 12 volts, and I'm going to verify that all my gains are turned down all the way counterclockwise to help limit the stresses on the output section in case there are any shorts. I've checked and I don't have any shorts that I am aware of. So all the potentiometers are fully counterclockwise. So I'm just going to pulse the pedal here while watching the lights. So yes, you have to have both fuses installed on these because they're treating it in 2 separate halves. So one fuse is protecting one side of the amp, the other fuse is protecting the other side of the amp. So I'm watching for my green light to come on, which I do have a green light. So we should see the switching up your upper left-hand corner of the screen there. So there is our power supply switching. So one bank, and then we should have the other bank. So as you can see, we do have good switching on the power supply. Let's go to our rectified voltage, which we have 30 volts negative, 31 volts positive on one side. We're going to have 31 volts positive, and should be the same, 30 volts negative. So now we should have our positive and negative rails on the output transistors, which, as you can see, we do in fact have those. So now what I'm going to do is I'm going to introduce a 50 Hertz signal into the amplifier, and we'll verify that the output is functioning properly on this amplifier. Which there's our signal. So as you can see here, we are at 50 Hertz on the signal. And then what we'll do is we'll fire the amplifier back up, and we will just simply check the output. And there we go. We have our output of 50 Hertz on one channel and 51 Hertz on the other. So it looks like we're even, 51 to 51.5 and 51 to 51.5. Voltage peak to peak of 46 volts on one side and 44.8 on the other side. So there we go. Simply replacing one faulty transistor. Replacing both actually to make a match set. And now you will see the amplifier is fully functional. Once again, another amplifier saved from the waste bin. Any questions, please leave them down below. And if you like repair content, please like and subscribe. I will be back with you again. Thank you.